Hi there, grade 12s. This is the last video on organic reactions that I'm going to make in my series, and the topic is the oxidation of alcohols. We will look at the oxidation of primary alcohols and the oxidation of secondary alcohols. Now, the condition to these reactions is that the oxidizing agent is acidified potassium dichromate solution, which is a beautiful orange solution, and I'd like to show you where it is on the table of standard reduction potentials, which appears on the data sheet. I use the table with the lithium at the top and the fluorine at the bottom. So in potassium dichromate you have potassium ions, which is a very weak oxidizing agent, and you have the dichromate ions down at the bottom, which indicates that it's a very strong oxidizing agent. But for it to be an oxidizing agent, it needs the hydrogen ions, 14 hydrogen ions for one dichromate ion. So the solution needs to be acidified. This is an orange solution, and it changes too during the spontaneous oxidation in contact with the alcohol. It changes into the chromium 3+ ions, which is green. So when you look at the practical, which is also on YouTube, the orange solution turns into a beautiful green solution. Now here we don't need to write a balanced equation for the reaction. Sorry, I just need to mention the second condition. We need to heat the reaction mixture. So our first example is the oxidation of 1-propanol. Sorry, I need to pronounce it correctly. 1-propanol. Oh, sorry. Yeah, I'm right. 1-propanol. Sorry. 1-propanol will be oxidized in the presence of acidified dichromate solution and some heat to an aldehyde, which we call propanol. So a primary alcohol will turn into an aldehyde. In terms of structural formulas, 1-propanol, you see it's a primary alcohol because the carbon to which the hydroxyl is bonded is joined only to one other carbon. So this turns into propanol, which is an aldehyde. Right. The intermolecular forces between the propanol is weaker, so the propanol is more volatile than the alcohol. So this is less volatile, and the reason for this is the intermolecular forces between the alcohol molecules are stronger. Because these two liquids are miscible liquids, they are separated oh my, making a mistake here. Alcohol and propanol are separated via fractional distillation because they have different boiling points. Right, the second example I would like to look at is that of ethanol turning into ethanol. So your ethanol in the presence of some heat energy and acidified dichromate solution will turn into ethanol. And the reason for this, I'm missing a bond here on this carbon. My humble apology, and I'm missing a bond on that carbon. You always need to take care to make sure that each carbon atom in your organic molecule has 4 bonds to them. Now this is not the end to these reactions. If you continue heating the reaction mixture and you've got an abundance of the dichromate, then, and you use a process they call reflux. So here I'm representing the little flask that can be used where the alcohol and the dichromate solution is mixed. If you have the privilege of seeing this, it turns green immediately. If you continue heating this mixture of the aldehyde and the carboxylic acid under what they call a process called reflux, then this aldehyde, the ethanol or the propanol, will continue the process of oxidation and form a carboxylic acid. So if under reflux you will have, and strong heating, the aldehyde will turn into a carboxylic acid. So we have the process in the presence of that strong oxidizing agent. An alcohol will turn into an aldehyde and under reflux conditions turn into a carboxylic acid. So 1 propanol turned into propanol, which will turn into propanoic acid. And for example 2 at the top there, ethanol will turn into ethanol, and that will turn into ethanol. acid. Right. The last oxidation of alcohols I would like to discuss is the oxidation of a secondary alcohol. So, secondary alcohol. A secondary alcohol, under exactly the same conditions of acidified potassium dichromate and heat, will turn into a ketone. And where the previous reaction was a stronger heating, it is moderate heating needed here, and obviously your acidified dichromate solution. I'm going to do one example of a secondary alcohol. So 2-propanol, 2-propanol will turn into propanone. So in terms of structural formula, just to indicate the difference, here we have the structural formula for 2-propanol. Just to make sure you understand that this is a secondary alcohol, because this carbon that is joined to the oxygen in the hydroxyl has got 2 other carbons joined to it. That is how you can identify a secondary alcohol, and that will turn into propanone. Right. This brings us to the end of my series of videos on organic reactions. I hope you found these little examples very useful in your study of organic chemistry. Thank you for watching. Bye bye for now.